Hello everyone, this is David, and as I promised in a previous video, I am going to do a couple instructional videos. The first one is multi-engine aerodynamics. So first off, let me just state a little bit about myself. I am a certified flight instructor. I'm a multi-engine flight instructor in the real world. So don't claim to be an expert on anything, but I'm not just blowing smoke. Anyway, so what I'd like to talk about today for our first lesson is our critical engine factors. So for the first thing, we need to talk about what makes an engine the critical engine, and that's what we're going to be talking about today. But let's talk about what a critical engine is. Okay, for the most part, in most Western aircraft, the propeller blades turn clockwise. Alright, so we have two clockwise turning propeller blades. Alright, this makes the left engine our critical engine. Alright, the critical engine is defined as the engine when lost that will have the most adverse effects on flight characteristics. Alright, so these four factors, P factor, accelerated slipstream, spiraling slipstream, and torque, go into making the engine a critical engine. So let's go ahead and dive in, and we'll talk about critical engine factors. Alright, so the first one I want to talk about is P factor. Alright, so the easiest way to understand P factor is at a high angle of attack, your propeller blade, your descending propeller blade is able to take a larger chunk out of the air and produce more thrust. Alright, when the aircraft is at a level flight attitude, the ascending and descending are producing this equal amount of thrust. But at a high angle of attack, they produce a different amount of thrust. This is due to two factors. Alright, the first is our relative wind. So we'll say this here is our relative wind, and it's blowing across our aircraft. Okay, relative wind moves parallel but in the opposite direction of our aircraft. So the relative wind is going off in this direction here. It's going off behind the airplane. Alright, so if we're at a high angle of attack, this outside propeller blade here, this descending propeller blade, alright, is going to be not only catching more air, but it's also going to be more aligned with the relative wind. That relative wind is going to be hitting it more on the face of the propeller blade than it is on the ascending blade, where it's almost going to be actually kind of hitting the back of the propeller blade. So it's twofold reason why P factor creates that yawing motion. One is because that outside propeller blade can take a larger chunk out of the air. The other is because, like I said, you're getting a larger chunk of air because of the aircraft's alignment with the relative wind, or the propeller's alignment with the relative wind. So, with that engine failed, okay, we're going to have a yawing motion into that dead engine. Okay, so that means we're going to have to use more rudder to counteract that engine. Okay, alright, we only have a limited amount of rudder available. So this is the first factor of what goes into determining a critical engine. Now you're asking me, well, why does it make a difference? Okay, well let's look at something here. Alright, so like I said, our propellers turn clockwise, most Western engines. So on this side, this is our descending blade. On this side, this is our descending blade. So this descending blade has a further arm from the center of the aircraft than this descending blade does. So the effects, I mean, it's like putting a breaker bar on a tire. You're just getting more leverage from this. So it has a heavier yawing effect than if you lost, or this engine was good and you lost this one. You're still going to get a yawing effect with if you had this engine running and this one was dead, but it's a lesser yawing effect. Alright, so let's move on to accelerated slipstream. Okay, so with accelerated slipstream, you have thrust being produced by that propeller. Okay, once again, you have that asymmetric blade loading. So you have the outside propeller producing more thrust than the inside one. All right. So, as you know, with a twin, that propeller is moving air over and under the wing, creating more lift. So there's more lift here on the outside. Okay. And definitely way more lift than on this side. This is just the wings producing this. There's no propeller slipstream producing the lift. All right. So what this does is this creates a rolling motion into that dead engine. Once again, we're having to counteract that with our controls. And there's a few things you can do, and we'll go into that when we actually go into the flying portion of the video, where I go up and I fail an engine, feather the prop, and go through the steps with it in another video. But what this is doing is creating a rolling motion into that dead engine. All right, because you're producing more lift. More lift makes this wing want to raise up and creates that rolling motion. So now you're saying, well, once again, what's the difference if I lost this engine died and this engine was okay? Okay, so once again, we are producing that more lift closer into the center of the airplane. Okay, so it's having less of a rolling motion into this engine. Okay, so that's another factor that goes into critical engines. All right, get that back up there. All right, so the next thing we're going to be talking about is spiraling slipstream. All right, this is one of my actual favorites to talk about. So let's get right to it. All right, so spiraling slipstream. Once again, this goes back to that asymmetric disc loading or asymmetric propeller loading. And so what's happening here is, and one other thing I do want to touch back on with the critical engine, or with the accelerated slipstream, because this is lifting this wing at a further out point, once again, it's a further arm from the center of the airplane, so it has more of that. I know that I did say that this had a higher rolling motion than this, but I did not touch on why that was, and that's just because it has a further arm from the center of the airplane, so more leverage to roll the airplane. All right, so going back to spiraling slipstream. All right, so once again, we are producing more thrust on that descending propeller blade, disturbing more air. So as this air moves back and this air moves back, it moves away from the airplane and moves away from the control surface. The reason for this is this disturbed air is a low pressure. This less disturbed air is a high pressure. Just like in weather, air moves from an area of high pressure into an area of low pressure. So that's taking that airflow away from our rudder and our control surfaces on the tail. So that gives us less rudder authority to counteract that yawing motion that the aircraft has. So this creates, once again, a yawing motion into that dead engine. Alright, so let's look at it on the flip side here. Let's say this engine's good and this engine has failed. So once again, we'll draw it out here. Alright, so we are producing our thrusts here, producing less thrust out here. Alright, so this thrust comes spiraling back into the tail. This thrust comes spiraling back into the tail. Alright, so our low pressure is now on this side. Our high pressure is now on this side. That's a horrible H, but whatever. So once again, that high pressure is going to be wanting to move to that low pressure. So we're going to get more effective control over our tail if our critical engine is not failed, as if our non-critical engine was failed. So we have more rudder to deal with the asymmetric thrust. Alright, let's get all that off there. Alright, so the last one, the final one, is torque. Okay, so torque is really pretty easy to explain. Like I said, in the West, our prop blades turn in a clockwise direction, and Newton's third law says that for every action there's an equal and opposite reaction. So that reaction is going to be get up there. That reaction is going to be wanting to produce a rolling motion into that dead engine again. Okay, so like I said, and that has to do with Newton's third law. The propeller is turning in this direction, so it's going to want to roll us in the opposite direction, equal and opposite reaction. So this is what goes into making an engine a critical engine, because let's say we lost this engine, or this engine was running. I have a picture of it. So your P factor is going to be less if this engine was running like it is in this situation. This one's feathered, so you're going to have less of a P factor. You're going to have less, or not less of a P factor, but your P factor is not going to have that arm from the center. Your accelerated slipstream is not going to have that arm from the wing like it would out from here. Your spiraling slipstream is going to be bringing that air back to your control surfaces, giving you more effective control of the aircraft. And our torque, okay, once again, is actually with this engine running. So we have that once again, propellers are turning this way, right? That torque is actually going to produce a rolling motion in the opposite direction and help us control the airplane a little bit better. But that's pretty much it with P factor. Once again, it's a leverage thing. With your critical engine running, there is less of an arm for it to yaw that airplane. With the accelerated slipstream, it's less of a yaw to roll the airplane. Spiraling slipstream, we have a more effective rudder and tail surface, fuselage, all that. The air hitting all that helps, even hitting the fuselage here, helps yaw the airplane into that engine, so we're not having to use as much rudder pressure to get that zero side slip. Our torque, once again, with that critical engine running, the torque actually helps us oppose some of that rolling motion from the accelerated slipstream. Alright, if anybody has any questions, please post them down below. I'll be more than happy to go into more detail. I plan on doing another lesson here really quick, talking about VMC, how they determine VMC. From there we'll move on into a lesson just about flying twins. We'll go up and get in the sim and we'll just go over some stuff, procedures that I like to use in a twin. Not saying they're right or wrong, it's just the way that I like to fly the airplane, and we'll go from there. But I hope everyone has enjoyed this video. Like I said, if you have any questions, comments, if I explain something wrong, post it below. Hey, you know, I'm not perfect. First thing as a flight instructor is admit your mistakes, admit errors. I admit that I make them. So if I've said anything wrong, please comment below. We can discuss it and we can figure it out from there. Alright, well, I hope everyone has enjoyed this video, and thank you for watching.